So hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 21 of the June daily Leetcode challenge, and we again have a hard level question in front of us. Yesterday also we had a hard question, but it was a really nice one. Okay, and today also we are having a similar hard question. You will see, as I told yesterday also, I will say repeat the same thing. Whenever there is a hard question, try your best, but always you should learn something from it. Okay, it should not be the case that you are tired of trying and you are not able to get the answer. So you should always try to learn something new out of a hard question. I will not say these are some of the questions. See, these are obviously hard questions. Even companies like Amazon and other big companies don't ask them directly such hard questions. They will ask in the medium level only. See, when I talk of the medium, it means there are some questions in the medium level which are on the easier side and some on the harder side. Okay, so in if you talk about Amazon and other fan companies, they will be targeting the harder level medium the medium level question which are on the harder side. Okay, that's what I wanted to say. And so what I want to say, see, when it comes to hard question, always try to learn something new out of it. It will definitely help you when you start trying to solve a easy or a medium level question. Okay, so even if don't get the whole solution, at least try to get something out of it. Okay, now coming to today's question, it's 2448 medium cost to make an array equal. Okay, it's very simple question to understand, but let's see how to see. If you talk about the brute force approach for this question, it's going to be very very easy. So definitely before after I explain the question, please try once to solve it in a brute force approach, and then we'll see the optimized solution. Okay, now I will start the question. So yeah, first see how the inputs are given. There are two arrays given. Okay, both are of same length. One is the nums array and one is the cost array. Okay, both are of same length. Now let's see the question. We are given two zero index arrays, nums and cost, consisting of n positive elements. Sorry, n positive integers. Okay. So one thing is clear, both are of same size and all the elements in them are positive. Okay. You can do the following operation in any one and sorry, you can do the following operation any number of times. Increase or decrease any element of the array nums by one. Okay. So this is a nums array. Okay. So I can increase or decrease any element by one. Okay. This is called one operation. Okay. This can be done any number of times, but there will be some cost involved that we are going to see now. Okay. The cost of doing one operation is the ith element of the cost of I. What that means is C. Okay, let me come to the question, then we'll come to the example. Return the medium total cost such that all the elements of the array nums become equal. Okay, so this is the question. Now let us deep dive into this. For example, I am at 3. Okay, I want this 3 to be equal to 2. Okay, so what I have to reduce this by 1. Okay, so here it's clearly mentioned whether you increase or decrease by 1. Okay, whether you increase or decrease by 1. So it doesn't matter whether it's increase or a decrease, always you will have to pay some cost. Okay, so in case of 3, when I talk of 3, the corresponding elements in the cost is also 3. Okay, that means I have to pay 3 points to make this element equal to 2 because I'm decreasing by 1. Okay, now let us take the other case. Suppose I'm at 5. Okay, suppose I'm at 5, I want this to be equal to 2. Okay, so what do I have to do? I have to reduce 5 by 3 times. Okay, I have to reduce 5 by 3 times. So that means I have to pay this cost 3 times. Okay, so 1 into 3 is equal to 3, so this cost should be paid 3 times. And if you come to this case, first of all, remember, decreasing this one and decreasing this by 1, both are different. Please pay attention here. Reducing, sorry, increasing this by 1 or increasing this by 1. Okay, the costs are going to be different. Okay, it's not the same. That's what they're trying to say. We have to find the minimum total cost such that all the elements in the nums array are equal. Okay, let us see this example now. Yeah, so what we're trying to do is we're trying to make all these three elements equal to 2. Okay, so when we talk about 1, I have to just add 1 to make it equal to 2. Okay, I have to just add 1 to make it equal to 2. So I have to pay 2 into 1, 2 cost. Okay, the cost will be 2 for this first element. Okay, now come to the second element. I have to reduce this by 1 to make it equal to 2. So what will the cost? I have to pay again 3 into 1, which is 3. Okay, that is the cost for the second element. Come to the third element, it's 5. Okay, if I have to make this equal to 2, I have to reduce this by 3. Okay, that means I have to pay the cost into 3, that is 3 times the cost. Okay, so this cost into 3, so it becomes again 3. Okay, so 1 plus 1 plus 1, which equals 3. So if you talk about the total cost, see this is obviously 2. I did not pay any cost to change it, right? So for the other 3, we have to pay some cost, and these are the cost. Okay, 2 plus 3 plus 3. Okay, which becomes 8. Okay, so the answer is 8. See, we tried to decided to that make these three equal to 2, but when you do it in a real way, that is when you code it, okay, for all generic cases, what you have to do is, see, You have to make, see, the best way, see, you can make them anything, but the best way possible is this is some hint which should come from the interviewer, right? The interviewer which you're going to, ask this question, he should give you this in that, instead of, for example, see, 9 is not among them, okay? Instead of making all of them to 9, okay, so 9 is not even a number here. What the interviewer should tell you is that you have to make it equal to any one of the numbers present here already, okay? So that should be the hint given. That means you are left with only 4 cases, okay? So either all of them could be made 1, either of them could be made 3, either of them could be made 5, or either of them could be made 2, okay? So for all these I have to find the cost, whichever is the lowest, that should be the answer. In this case we directly know that 2 will be the least cost. How we know? It just, they have simply, explained that 2 is the answer and we are finding it, right? But in general, in if you are solving solution for a general case, we will have to find the cost of making all these one by one. See, for example, first we have to try to make all of this equal to 1, okay? The cost for that. Then we have to try to make all of this equal to 3, the cost for that. And then we have to try for making all of this equal to 5, and the cost for that. Similarly for 2, we have to compare all the 4 costs, which is the lowest, that should be the answer, right? That is how it will be done in the coding part, right? And you can see the other examples as well. See, here all are equal, so we don't need to, do any modification. That's why we are not going to incur any cost. Coming to the constraints, it's going to be 10 power 5, okay? We cannot have an square approach here. See, that's what I was telling in the starting itself. This question can be very, very easily done once you get this in that, you have to make, you have to see, the interviewer should tell you, you have to basically ask this to the interviewer, that whether we should, make the, see, the numbers are 1, 3, 5 into, right? Instead of making one of them, can we make it as a separate element which is not even present here? If the interviewer says no, then you have to go up, come to this approach. The approach which we are going to discuss is like that, okay? We are not, going to make it any element outside this nums, okay? Any one of the nums element only will be the one in which all the elements will be transferred, okay? All the elements will be transformed. That's what I am trying to say, okay? That's what is the answer. And yeah, let's see the coding part. As I mentioned, see how to do it in a brute force approach. I will tell you that because see, these things are very important. See, when you are talking about the interview perspective, first you have to solve it in a brute force approach only. Because even if you solve in the optimizer in the starting, definitely the interviewer will ask you to solve, optimize it even further, right? So it's always good to solve using a brute force approach first. Okay, let me tell you how to solve in a brute force approach. But first, make this point very clear. See, our aim is to make this all into one equal to one first. Okay, take the cost for that, make this all equal to 3, take the cost for that, make this all equal to 5, take the cost for that, make this all equal to 2, take the cost for that. The fun they have given is the cost for 2, okay? Making all of them into 2, okay? They're transferring all of the numbers to 2. Similarly, take all the 4 costs, take the one which is the lowest, okay? For doing that, how you should do, okay? Very simple. You will require a O of n square approach. How? First, make a loop to iterate to all of the elements. Second loop, you should calculate the cost, okay? If you do in that way, see, the idea is, suppose in the first loop I'm selecting one, in the second loop I should select all of them again. I have to, visit all of them again to calculate the cost, right? That's why 2 loops will be required and it will be O fan square approach. You did not have any space complexity, it will be constant space complexity. But because this is a bigger, yeah, I have tried myself, basically speaking, O fan square approach will not be accepted, okay? So we have to try an even optimized approach, okay? So what I am going to do is, it's very, very simple. See, what we'll be doing here is, see, I will be finding the full cost manually for one of the elements. After that, I will be doing some, tricks and maths involved to get the cost of the other elements and without doing the whole calculation again. That's what is going to be done. Let's see how it works. Okay. So yeah. So I hope these things will be clear to you. Okay. So what we are going to do is, okay, let me show you this image first. See, we are going to sort the array based, not based on the cost, but based on the nums. Why we are doing that, I will show you in this image. Okay. For example, see, once I sorted based on the nums, okay, what means is, see, for example, this number is 3, okay, this number is, yeah, as you can see here, we are going to solve them based on the nums, okay. For example, this number is 3, so all the numbers to the left of that will be smaller than that, and all the numbers to the right of that will be greater than that. That is the basic idea here, okay. That's what we are going to do. Then see, as I mentioned, see, for the first number we'll be calculating the cost manually, okay. After that, for all other cases, we will be making the modifications to the calculated cost. We will not calculate it again separately, okay. We will simply make some modifications to the calculated cost. That's what will give us the answer, okay. That's what is being shown here. See, first we calculate for the first dotted line, okay, at the bottom. Then we are going to, calculate for a second number, just by knowing the gap between the two, okay. That's what is being shown here. Delta x will basically refers to the gap between the two numbers, in which, for example, this number becomes, let us say, is 3, okay. For 3 we know, then we are going to calculate for 4, so the gap between them is 1, and using this gap, we know the answer for 3, right? The total cost. This cost, knowing this cost and knowing the gap that is equal to 1, we'll calculate the answer for the number 4. Okay, that is the basic idea. We'll see how it works. But just remember one thing: we'll be using the sorting. Okay, we'll be using the sorting. We'll sorting the nums. Okay, you can see here that 1, 3, 5, and 2 is there. We'll sort it basically to make it 1, 2, 3, and 5. Why we are doing the sorting? It will become more clear when we see the coding part, right? See, the basic idea here is, see, for example, if I am at 3, okay, so it clearly means that all the numbers which left will be less than that always. Okay, there will never be a case where the numbers are not less than that. Okay, here the numbers will definitely be less than that, and the numbers which right will be greater than that. So it will make our calculations a bit easier. Okay, instead of having it in a present in a random way, we are sorting it. So basically, the sorting requires the analog and complexity, and this is the only going to be the something which is consuming a lot of complexity. Rest all will be off an approach only. So yeah, let's see the code part. So yeah, I hope this thing is clear. Just remember, we are going to sort it based on the nums. Okay, but remember one thing: when we are sorting based on the nums, as you are seeing here, remember the number one is associated with this cost. Okay, if I sort this, the relation will break. Okay, for example, number 5, so number 2 has a cost 14, but if I sort it, this relationship would break. Okay, so I have to sort in such a way that this relationship should not break. So 2 always should be associated to 14, 73 always should be associated to 3. Okay, that is the basic idea. So what we'll do is make them in a you will pair them and then you will sort based on the numbers. Okay, we'll see that in the code. So yeah, here that's what we are doing. Okay, see this nums and cost, we are combining them, aggregating them into a single you know data structure, and that's what we are doing here. Okay, see the first in this, every element will have two things. Okay, in this data structure, nums and cost, it's being called. Okay, so every element will have two things. The first one will be the number at that index, and the other one will be the cost for that index. Okay, that's the basic idea. So, okay, so don't go for what is zip and all. There are much easier ways to do that. Okay, don't go for this. You can use a simple for loop and range function, and you can get it. Okay, zip basically means that, see, nums is array, cost is also array. It will break them open at once. Okay, so first element of nums and first element of cost will be paired together, access together. That's what is the function of zip. I don't expect these things to be, you need not be aware of these things. This is just a way of doing it. You could have done it in the other way also, using the range function and using the variable I. Okay, so I hope these things are clear to you now. So idea is very clear. See, we are going to make this a new data structure. Okay, each element of this data structure will have, it's basically a combination of these two. The first 0th index will be the nums, which will represent the nums of that the index. The first index. Okay, see, this is the 0th one in each element, and this is the first one in each element. Okay, this will represent the cost. Finally, we're taking the length of the array, and it's clearly mentioned here. Okay, that's why starting itself I focus on this point. Both of them have n positive integers. Okay, that is the basic idea. And finally, we are going to use the prefix sum cost here. Okay, the idea is we are going to use a prefix sum, and I will show you in images also how it works. Okay, so we are going to calculate the prefix. See, remember, this prefix sum will be only for the cost and not for the nums. Okay, we will only aggregate the cost and we'll find it. Okay, the cumulative cost. Okay, for each index. So initially, see, please make this point very clear that 0th index is the num, first index is the cost. Okay, so here we are taking the first index. Okay, for the nums and cost array, we are going for the 0th element and we are taking the cost of it. Okay, this first one you are seeing the index, it refers to the cost. Okay, we're taking the cost of it, which will be my first element of the prefix cost. Okay, see, whenever we talk about cumulative, sum, first index should be defined, right? That's what we are doing here. Then we are starting from the range 1 to 9, okay? And then we are taking the prefix cost. What we are doing, see, this, please pay attention to the names, others it will differ for you to understand. This is a prefix cost, right? It's prefix cost of y. We are adding, see, what will be prefix cost of y? It will be the previous prefix cost, that is the I minus 1 prefix cost, plus the current cost, okay? So this is the I minus 1 prefix cost, okay? You can clearly see I minus 1 here. This is the previous element of this, okay? Suppose the ith element, this is the I minus 1th element of that, okay? And we are adding the ith element, nums and cost, that is the first index of the ith element, okay? So as I told, first index refers to the cost, okay? The 0th element refers to the nums, okay? So here we are adding the cost of the ith element, okay? And we are adding the previous element. That is what is referred to as cumulative sum, okay? I'll quickly show you what it means, cumulative sum means. For example, see here, for example, it's 2, 14, 3, and 1. Okay, so initially it will be 2 only. The next element will become 2 plus 14. Okay, it will become 16. The next element will become 16 plus 3 becomes 19. And the next element will become 19 plus 1 is equal to 20. Okay, so what we are doing every step, we are adding the current element, sorry, the current cost and the previous cost. Okay, both of things we are adding. Okay, that's what is called cumulative cost, or prefix sum of accumulation. That's the basic idea. And yeah, as I mentioned, now we will be calculating the total cost. Okay, and so this will be the one of the answers. Okay, this will be one of the answers. We will be calculating the total cost for the zeroth element. Okay, and then on we will be using that particular variable to we will make some modification to that variable and get the answer for the other indices. Okay, so what we are doing here is basically we are trying to make all the elements equal to the first element. Okay, the first, see, we have I will again repeat, see, we have sorted the things, right? For example, here this symbol like that, and we have sorted it. So this one is in the zero next, right? Now we will try to make all the elements equal to this element. Okay, so this 2 will also become 1, this 3 will also become 1, this 5 will also become 1. Okay, we'll now try to calculate the cost involved in that. Okay, that will be calculating here. Okay, that's what code I have highlighted here is you are seeing here. Okay, from then on, what we'll do is, from the next index onwards, what we'll do is, where is that? Yeah. For 2, 3, and 5, what we'll do is we'll do some manipulation in the result of the first index. That is, when we see for one we calculated the total sum manually. Okay, it is the whole calculation in that, but we'll not do that whole calculation again. Okay, simply for the result of one, we'll do some manipulations and get the answer for 2, and similarly get the answer for 3, get the answer for 5. Then take the smallest of them. Okay, that's what we are going to do. So it will be a really nice approach. If pay some more attention, you will definitely get it. Okay, what we are doing is, see, total cost, this is the variable. Okay, initially it is 0. Okay, remember one thing, the answer which you're going to return is going to be the smallest of the total cost. Okay, please pay attention to this variable wherever it is used. Okay, so what I'm doing, I'm starting from index 1. Okay, why I'm starting from index 1? Because, see, I'm going to make all the elements equal to the zeroth element. Okay, equal to the zeroth element. So zeroth element is already equal to itself. Okay, so all the elements, see, first element is 1, right? I have to make the element starting from index 1 equal to 1. Okay, that is the basic idea. That's why I'm starting from the first index onwards. So total cost is equal to, I'm adding to the total cost. What I'm adding, see here, the gap, sorry, this is the cost for that. Okay, see, this is the cost of the ith element multiplied by the difference between the elements. Okay, this is the cost, sorry, this is the lumps of, remember, this is the ith element and this refers to its number. Okay, this is the ith index, sorry, zeroth index. This is the zeroth, sorry, one second, this is the zeroth index. Okay, and this 0 refers to its number. Similarly, this 0 refers to the number of the ith index. Okay, so what we're doing is, as I mentioned, for example, see, this 3 has to be, sorry, this 3 has to be 5, this 5 has to be converted to 2, means I have to subtract 5 minus 1. Sorry, this has to convert to 1, means I would subtract 5 comma minus 1, which will give me 4. This 4 has to be multiplied with the cost of this 5. Okay, which is 1. That's what we're doing here. I am first subtracting them to understand how much is the difference. Then we are multiplying it with the cost we will have to pay for making that change. Okay, that's what we are doing here. Okay, so zeroth variable where you are seeing is basically refers to the number. Okay, not to the cost. And wherever you are seeing this 1, it will basically refer to the cost. I hope this thing is clear to you. We are making all of the elements equal to the first element. Okay, we are making all of the 2, 3, 5 equal to 1. Okay, that's what we are doing here, and we are getting the cost. Now comes the most important part. So please pay attention to understand. See, now what happens is, I have the cost. Okay, I have the cost for the first element. Okay, yeah, and where is that image? Yeah, so what happens is, I have the cost for the first element. Now please pay attention to what is happening. See, for example, I have the cost for 1. When I make all the elements equal to 1, what is the cost? I know that. Now I want to make all the elements equal to 2, but I will not do it manually. Okay, I will simply use the result for the first index, and I will be making change to that to get the answer for 2. What we're doing, see, try to understand. Initially 3 was reduced to 1. Okay, but now I want to be reduced to 2. So what happens, see, initially my answer involved the all addition of these things. Okay, but now I have to reduce that from my answer, because see, previously what I did, I added 2 to my answer. Okay, for example, 3 should be reduced by 2, right? 2 into the gap, sorry, 2 into the cost to my answer. But when you talk about 2, when I want to make it equal to 2, I shouldn't have multiplied with 2, I should have multiplied with 1. Okay, 1 into the cost. Okay? So I have to that means I did more reduction than it was needed. Okay, so when we talk about all of them making equal to 2, so we have to reduce that. Okay, so for all the elements to the including 2 to its right. Okay, we have to subtract the gap involved. Okay, at the same time, when I talk about the first element 1, you can see it was 1 in the first step, but now we are talking of 2. Okay, we are trying to make it 2, so we have to include this cost. Okay? So there will be inclusion. See, all the elements to the left of 2 include their cost gap. All the elements to the right of including 2, you will have to reduce the gap. So you have to do a subtraction here, and for all the elements to the left, you have to do addition here. I will just show you in the code and I will come back to it, because I know this is the most difficult part. Even I took some time to understand it. But once you get some examples, you will make it very clear. Okay. First we'll see the code and then we'll go for the examples. So please pay attention here. First we are trying to talk about the gap. What is the gap? See, gap means that number minus the number from which we are trying to make it. Okay. So this is the ith element. Its number minus the I minus one element number. Okay. Remember, we are talking about nums and cost. Okay. For I in range, and we're making this. Okay. This is the gap basically. Okay. The ith element minus its previous element. Okay. So this is the gap. Now comes the most important part. Yeah. Now we see, as I told you, one thing will be added and one thing will be subtracted out of it. Okay. What is the added? See, we are now talking about prefix cost. See, this is what I told you initially. All the elements to the left of 2. See, I am trying to make all of them equal to 2. Okay. So all the elements to the left of 2. How I know, see, how to refer to the number? That is what is the prefix cost of I minus 1. That is what is the prefix cost of I minus 1 into the gap. Okay. So this is the, so remember, prefix cost is a prefix sum of the cost, not the number. Okay, please make this point very very clear. Prefix cost is sum of the cost, multiplying that with the gap. Okay, yeah. Now comes the second part, all the elements to the right of it. Okay, all the elements to the right of it. Okay, what happened is, see, I made them equal to 0, but when I talk about 2, see, so obviously 2 is greater than, right? See, if you talk about how far to reduce 5 to 1, you have to subtract something more, right? But if you talk about to reducing 5 to 2, you have to subtract something less. Okay, so what happened is we subtract something, very large number. Okay, subtract in the sense we added to the cost a very large number. Now I have to subtract from it. Okay, that cost. Okay, that's why we are doing a minus here. Okay, gap into, see, as I told you, including the current number I have to take. Okay, so including 2, that is including 2 till the nth. Okay, nth element. So n minus 1, that is the last index till then. Okay, that is the basic idea. This is what we are doing. Prefix cost of till last element. Okay, the cost is the last element. See, remember, this is the prefix sum, this is the accumulative sum minus the previous elements, that is I minus 1 previous cost. Okay, why you are taking I minus 1? Mm, I hope you would have understood by now. See, I want 2 to be included. Okay, 2 is the ith element, right? I want 2 to be included. That's why I will take the I minus 1 prefix sum. I will subtract from the the last element prefix sum. I will subtract from I minus 1. Why I'm doing I minus 1? Because I want 2 to be included in that. Okay, that's what we're doing it. That's why we are subtracting it from the I minus 1 element. Okay, yeah, that is the basic idea. And yeah, this will be added to the cost. Okay, finally I will be getting the cost for the ith element here. Okay, now this cost I will just try to compare it with my answer. Whichever is the minimum, I will take that into consideration. This loop will be running for each of the cases, and then we'll get the answer. I will trace and show how it works. Okay, see, initially I will try to make all the elements equal to 1. Okay, so for every number once, okay, we'll check the cost of making it equal to the nums of I starting from the nums of 0. Okay, that's in the next case. Now let us see how to make it 1. Okay, see, 1 is already 1, right? 2 I have to reduce by 1 to make it equal to 1, so I have to pay the cost 1 time, that is 14. Okay, 3 I have to reduce by 2 times to make it equal to 1, so the cost will be 2 times of 3, which is 6. Okay, similarly 5 I have to reduce by 4 times to make it equal to 1, so the cost will be 4 times of 1, which is 4. So if you add them, you are getting 24. Okay, that is the first case where we are doing manual calculation. Okay, in all other cases we'll be directly referring to 24, make changes to 24 and get the answer. We'll see now. So please pay attention to this step now. Okay, now I want everything to be equal to 2. Okay, what I have to do, I have to make 1 also equal to 2. So what I will do, so the cost is 2. Okay, so I have to make one more time greater. Okay, so I have to add 1. So for adding 1, I have to pay the cost a single time. So 2 into 1, 2. Okay, this was to be added to the total cost of previous. That is, see, this total cost is coming from here. Okay, here answer is 24, right? This is called the total cost now for the next step. Okay, this is the total cost. Now please pay attention. Now comes the most important part. See, this 2, sorry, this 14 plus 3 plus 1, which is equal to 18, right? This 18 should be subtracted 1 time. That is the number of gap. Okay, see, the gap between 2 and 1 is 2 minus 1 equal to 1, so the gap is 1. So 14 plus 3 plus 1 should be multiplied with gap, which is equal to 1. So 18 into 1, that is the one which we are going to subtract. Okay, how 18 is coming? 18, 14 plus 3 plus 1 is 18, right? How 1 is coming? The gap between 1 and 2 is 1. Okay, so whatever is the gap, that we are going to multiply it. Okay, so 18 should be subtracted. So what it becomes, the cost was 24 here. Okay, 24 plus 2 becomes 26. Okay, 26, and now you're going to subtract 18 from it. Okay, 26 minus 18, it will remain with only 8. Okay, that is the idea. Now we'll go to the next case. Okay, The next case is making things equal to 2. Okay, so 2 and 14. Okay, so first of all, what is the difference between 2 and 3? Okay, it is 1. So we'll be so the gap is 1 basically. Okay, so now what we are going to do, see all the elements to the left. Okay, this should be added. So 14 plus 2, which is 16, should be multiplied with gap, which is 1. Okay, what is the gap? 3 minus 2 is the gap, right? So it is 1. Now all the elements to the right of 3 including 3, that prefix sum should be, subtracted by multiplying with the gap, which is equal to 1. So 3 plus 1 is 4. I'll multiply 4 with 1 and subtract it. Okay, so this is what we are getting as the answer. So please do the calculation yourself, and this is the answer we are getting. Okay, so similarly you have to do one more time, and this is for 3, you have to get it for 1 also, which is the last, and you have to, for all the answers, you have to take the smallest one possible. Okay, so yeah, friends, that was the idea. So what happening here is, see, this is the only calculation we are doing. Okay, after that we are just adding something and getting the answer for the next indices. Okay, all the next indices. That is the basic idea. If you talk of the time complexity here, see, I told you one brute force approach, right? For each taking a two loops and doing it, that will be a square approach. If you talk about this time complexity, we are doing a sorting here, so because of that, it will be n log n approach. Obviously, we are using a prefix array, so that also will take uh, O of n time. Okay, so space complexity O of n, time complexity O of n log n. Okay, so yeah, friends, that was the idea. It was slightly tricky question, but I definitely felt that you should have learned something from it. Okay, there's definitely so much to learn from it. Okay, we are using how the prefix array is being used, how the prefix sum is being used, and how we are multiplying it. Okay, so this really, I felt really happy after knowing the answer for this and understanding the answer for this. I hope you would have also understood. See, we did sorting. Why we did sorting? Because once I did sorting, so suppose I'm at number x, so I know that all the elements to the left of x is going to be smaller than that. So that's, see, once I get that, see, all the elements to the left of that will be smaller than that, all the elements to the right will be greater than that. After knowing that, only these things are coming. Okay, these are possible. So we are simply adding it. As you can see here, we're simply adding it because I know it will be smaller, so we have to raise it. And I'm subtracting for all the elements to the right because I know they already, great amount of them is adding get added to the previous answer. That's why I need to subtract that, make it smaller. Okay, that's what we're doing. So this is possible only because we sorted the array. So yeah, friends, yeah, I'm really tired explaining you, but I hope I have touched every part here, every part of the code here, and I've given you the best possible explanation. So when in doubt, please pause the video, rewind it again. Before that, please solve it using a proof approach. See, understanding this question still will take a lot of time. That's I really understand, because you have to understand each of the edge cases. So yeah, I hope I've tried my best to explain you. See you tomorrow. Thanks a lot.